Okay. All right. Okay, Giselle, thank you for meeting with me. And like I said, again, this is just about me helping to see how I can help you solve this problem, okay? So what I'd like you to do right now is just take a moment to read this problem and let me know when you're done. Read it as many times as you need. Just let me know when you're done, okay?
You have to read out loud.
Sure, that'd be great.
Sue and Julie were running equally fast around the track. Sue started first. When Sue had run 9 laps, Julie had run 3 laps. When Julie had completed 15 laps, how many laps has Sue run?
Okay, thank you. Can you tell me in your own words what the problem is asking? And you can feel free to write all over. I gave you some paper here. Feel free to write on that. What do you think the problem is asking?
How many laps does Sue run?
Okay. Tell me in words, how would you go about solving this problem?
Ratios?
Ratios? Okay. Can you show me how you would solve these ratios? Okay, can you tell me in words what you did to solve this problem?
I did 3 on ratio and then x on the bottom, and then equals 9 to 15. And then 3 times 3 equals 9, and then 15 times 3 equals 45.
Okay, so what do you think is the answer to this problem?
45.
Okay, can you say your answer into the sentence that you were wanting to answer?
When Julie had completed 15 laps, Sue ran 45 laps.
Okay, so, alrighty, thank you. Alrighty, now, when you went about solving this problem, did you consider the time difference of when they started? Do you think that would have affected or changed the answer at all?
No.
No, you don't think it would change? Okay. So I want to look at this picture. Did they start running at the same time?
No.
They didn't start running at the same time? But you don't think that's going to affect the answer?
Yeah, I think.
You do think why do you think it's going to affect the answer?
Because Julie's going to run more than Sue.
Julie's going to run more than Sue. Okay, that's a very good thought. Alrighty, so why don't we draw a picture real fast? Can you draw a track for me?
A track.
Just like you know, a track as a circle. Okay, just draw a circle for me. So, who started running first?
Sue.
Sue. Okay. What do we know about the number of laps that Sue ran?
She ran 9 laps.
And how does that refer to Julie?
Julie had run 3 laps.
Okay, so you said Sue ran more laps than Julie, right? So show me 1 lap that Sue could make.
From here to here. Wait, no, from there
all the way around. Okay, that's 1 lap, right? Has Julie started running yet?
No.
No. Okay. What about? Can you show me another lap? What would another lap look like?
Should we just start from here and go around?
Okay. Yes. So what makes a full lap?
From one end to the other.
Okay. Does it matter where she starts? No. It's just as long as she goes all the way around, right? Okay. Good. So, how many laps do you think Sue had run before Julie started running?
Can you repeat the question?
I can, yes. How many laps do you think Sue had run before Julie started running?
1.
1? Okay, why do you think 1? What can you show me in the problem that you think 1?
Because if Julie hasn't started, then she would have run one lap, and then when Julie started, she run 9.
Okay. So you think Sue ran 1 lap and then Julie started right after her. So then would Julie be 1 lap behind Sue? No? Okay. How about, let's look at it this way. The question says, when Sue had run 9 laps, Julie had run 3 laps.
Yeah.
So what does that mean to you, the 9 laps and the 3 laps?
If Julie runs another 9, Julie would run another 3.
Okay, yes, you're getting there. Except, did these girls start at the same time? No. Okay, and so the fact that they didn't start at the same time is what's going to change our answer a little, okay? So, why don't we look at a table, okay? So let's create a table, and so let's title it Sue and Julie. Okay, so what do we know about the number of laps Sue ran and that Julie ran?
Sue had run 9 laps.
Uh-huh. And Julie had run how many?
3.
3. Okay, so they're both running now, right? So what do you think, how do you think you could continue this table going in increments of 1, only increasing by 1 lap?
Can you repeat the question?
Okay, well, you tell me, how do you want to continue this table?
Adding another 9.
Adding another 9. Okay, so what would you do if you added another 9?
And make 18.
Right, and how many laps would that be for Julie?
6.
Okay. So continue that until you get to Julie's 15 laps. You're close on this one. What's 18 plus 9?
27.
Yes.
Yeah.
Mm-hmm. So what do you notice about the table and the proportion?
Sue had run 45 laps and Julie had run 15.
Okay, did you get the same answer each time?
Yeah.
Okay, so how confident do you feel about your answer being 45?
Good.
You feel pretty good about it? Okay, so let's just go back and look at the question. When Sue had run 9, Julie had run 3, right? So you're saying it's a 9-to-3 ratio. Okay, now, when we look here, you're saying when Julie had run 15, Sue had run how many?
45.
How many times more? 15 times what is 45? And you did it here if you need help.
Times 3.
So you're saying Sue ran 3 times more than Julie?
Yeah.
Yeah? Okay. Now, what if I asked you to make a table another way? Do Sue and Julie again. And I want you to start at 1 lap, okay? When Sue had run 1 lap, how many laps do you think Julie will have run?
None.
Right, good. Why none though? Why do you say none?
Because Sue started before Julie.
Right, okay. When Sue had run 2 laps, how many do you think Julie would have run?
1.
Let's go back to our question. What do we know?
Sue had run 9 laps and Julie had run 3 laps.
Okay, so are we at the 9 laps for Sue yet?
No.
So how many laps will Julie have run?
None.
Right. So when Sue had run 3 laps, how many laps do you think Julie will have run?
Nothing.
Okay.
It's gonna keep going on.
Okay. Until what?
9.
Okay. Show me that on the table.
That's what she meant to be.
Okay. So why did you put that there?
Because Sue ran 9 laps and then Julie ran 3.
Okay, very good. So now, are they both running?
Yes.
So they're both running. So are they running, could they be running side by side right now?
No.
They couldn't be?
Yes.
Why do you say they couldn't be?
Because she ran before her.
Right. But does the problem say anything about how fast they're running?
Mm-hmm.
No. Okay. But we know that Sue started running first, right? Okay, so if when Sue gets to 10 laps, so she put 10, how many laps do you think that would be for Julie?
4.
4, okay. Why 4?
Because 9 plus 1 equals 10 and then 3 plus 1 equals 4.
Okay, very good. And what do we know when we get to those 9 laps? What do we know about Sue and Julie? They're both doing what?
Running.
Running, okay. So continue that table.
Bowen.
Yes. What do you notice is different about this table from this table that you set up?
This one is going to be faster to get to 45 and this is going to take longer.
Okay, so do you still think your answer is 45?
No.
Why not?
Because Julie already ran 15 laps.
Okay, and when Julie had run 15 laps, how many had Sue run?
21.
21. So our answer is the same? No. Okay, which answer do you think makes more mathematical sense?
No.
This one? Why this one?
Because if Julie already ran 15 laps, so we already ran 45.
Okay. So do you see the proportion in this problem? The way you set it up here? Okay, so you're saying every 9 that Sue runs, Julie's going to run 3. Okay, what if I would have told you this would be correct if they had started running at the same time?
How?
Okay, because at the same time, this would mean Sue would be running 3 times faster than Julie. Okay? And so for every 9 she runs, Julie's only able to run 3. But in this problem, did they start at the same time? No. And so we don't know anything about their speed, right? We just know when Sue ran 1 lap, how many did Julie run? Nothing, right? And when Sue ran 2, how many did she run? Nothing, okay? Good job. So we got down here. When Sue ran 9, Julie had run 3. So what is the difference in the number of laps Sue has run before Julie started running?
Julie ran less than Sue.
Very good, very good. Can you find out if Sue has been going around the track 9 times, by the time Sue had gotten to the 9 times, how many times had Julie gone with her? 3. So before Sue got to that 9, how many laps do you think before Sue got to the 9 and before Julie joined her, how many laps do you think Sue had been running? No. Okay. All right. Let's look at it. Can I see your pencil, please? When she ran 1 time, we're at 0, right? 2 times, we're at 0, right? By the time Sue got to 9, Julie had been running how many?
3.
Okay. How many do you think Julie would have been running when she was at 8?
2.
Yes. And how many do you think she would have been running when Julie would have been running when she was at 7?
1.
1. So, how many laps had Sue run, complete laps had Sue run before Julie started?
6.
6. So, Sue had been doing like a warm-up lap, right? And she ran how many laps?
6.
6. But once she got to that 6th lap, after she finished that 6th lap, who joined her?
Julie.
Julie did. So now, are they running, could they be running at the same pace together?
Yeah.
So as Sue finished another lap, is Julie finishing another lap?
Yeah.
Yes. So they could be running together right now, right? So at the very end, when Julie had only run 15, how many had Sue run?
21.
And what is that difference right there?
Sue ran more than Julie.
Right, she did. How many more did she run?
21. Wait. 6.
6. So how many more laps had Sue run before Julie started?
6.
6 laps. So by the time when they were done running laps, they didn't run the same number of laps, right? No, because Sue had run how many laps prior to Julie showing up?
6.
6 laps prior to Julie showing up. So now, with that thought, which answer do you think makes more mathematical sense? This one or this one?
This one.
Why do you think, and can you say which one that is?
21 to 15.
Okay, why do you think this one makes more mathematical sense?
Because when Julie finished 15 laps, Sue finished 21.
Okay, and what does this one show for the laps that Sue ran before Julie started her? Which table that you made has allows for the time when they started at different times?
No.
At different times.
Oh, no,
This one, okay? Now, one more thing that we want to look at the question. What's the very first sentence to this question?
When Sue had run 9 laps.
The very first sentence.
Oh, Sue and Julie were running equally fast around the track.
Equally fast around a track. So, they were running at the same speed, right? But, did they start at the same time? No. And did we show that they didn't start at the same time with this table? So, Sue got there first and ran how many laps before Julie joined her?
6.
6, okay? Once she finished that 6th lap, she saw Julie and said, "Hey, Julie, join me," right? And did they start running at the same speed the whole time as they went around? So as Sue completed 7 laps, Julie had only completed 1. But did they keep going together?
Yes.
Yes. So then at the very end, when Sue finally said, "I can't run anymore," she had run how many laps?
21.
Compared to Julie's
15.
15. Now let's look at this table. Does this table show them running at the same speed?
No.
No. This table is going to show them starting at the same time, but who's running faster?
Sue.
Sue. How many times faster?
45.
Or what's
30.
You're close. What is not the difference, but how did you go from 3 to 9? So she was running how many times faster?
3.
3 times faster. Very good. Okay, so now can you explain to me what the difference is between this table and this table?
This one, when Sue finally gave up, she won 21. And
Okay.
Julie won 15.
15, okay. What does this table show that this table doesn't show?
This one shows how much Julie ran and Sue ran, but the difference.
The difference, and the difference including the what?
The 6.
The 6. Okay. So what I want you to understand is the time. The fact that they didn't start at the same time is important. Okay? Which table do you think shows that they didn't start at the same time?
This one.
Why does this one show that they didn't start at the same time?
Because whenever Julie ran when Sue ran 1, Julie ran nothing.
Okay.
So whenever Sue ran 6, she didn't do nothing. But
Okay.
when 7, she ran 1.
Okay, very good. So this one shows the different times. Does this one show a different time?
No.
No, because what you said is for every 9 that Sue runs,
She ran 3 laps.
she ran 3 laps, right? And that would have worked if they would have said they started at the same time. But did they start at the same time?
No.
No. So in the end, which answer makes more mathematical sense?
This one.
So when Sue had run, how many laps?
21.
Julie had run
15.
15. Very good. Okay, so do you have any questions about the problem, or what confused you about the problem?
This one.
That confused you about the problem? Why did that confuse you?
Because I thought when she runs 9 laps, I thought she ran 3.
Right, and you wanted to keep increasing by 9? Okay, so this would have worked if they would have started at the same time. But since they didn't start at the same time, and they were running at the same speed. So you had to equate that. This one shows that Sue was running 3 times faster than Julie. And the problem says that they were running equally fast around a track. So does this one show that they're running together now? Because they're both increasing their laps by how many?
1.
1. So as Sue runs another 1, Julie will run another 1. Okay, alrighty. So in the end, can you read your answer in this sentence?
When Julie had completed 15 laps, Sue had finished 21 laps.
Very good. All right. Well, thank you so much, Giselle. You did a great job.